Few minutes. People joining, so we are live. We can start. So welcome everybody for this YFTT that we do every Friday from engineers to engineers. So it's really about features and engineering behind the database. And today we have Dorian. If you have opened some questions on the forums, on Slack, basically the community, then probably you already know Dorian is managing the community answers in the different channels that we have, maybe on Stack Overflow also. Dorian, are you there? I don't see.
Yeah, I'm here.
Yeah.
So we can start.
So I think we can start. I'll let you introduce yourself quickly and let's go.
Hey everyone, I'm Dorian and I work here at Yugabyte as a community success engineer. And I work mainly with the users and customers on the day-to-day issues. Today we'll check a common collection of issues around schema migrations and some best practices that we can follow to when we hit them, or hopefully not to hit them at all.
Perfect.
So,
And if there are any questions on the chat on LinkedIn, please ask questions and we will
yeah, I
answer
can
that.
see the comments on LinkedIn too. Yep.
Yeah, perfect. Okay, let's go.
So I've previously worked with Postgres mostly as one of the best open source databases that have a great schema migrations feature set. And you can have a transactional DDL and DML in a single transaction. You can basically rewrite whole tables, change primary keys, do data migrations, all or nothing in a simple single transaction, and everything, and it's a great experience and everything works great. But this works great until it does not. The issues usually happen when you have a lot of data. So you're just trying to, let's say, rewrite a very big table with a couple of indexes, or you are using synchronous replication and you need to wait for it to happen, or you also have heavy load. So now that you're doing the big migration / transaction, the load becomes even heavier. You might have multiple region deployment, so less bandwidth and higher latency there, and everything in between, or all of them, and also other applications that are using the database compared to the one you are just migrating. And usually what happens is that it works fine on the dev machine when he does the migration with an empty table. It worked fine on CI when probably also an empty table or something. So the staging cluster was on, it's never under high load, so kind of mostly breaks in production usually. So what we can do in this case is the simplest one is just to make sure that everyone knows what anything that can go wrong and just doesn't do the errors. Another way is to simply have one guy who mostly knows everything that can go wrong, and he can review your migrations or pull requests. Another way would be to have two guys for redundancy. This works up till a point, but yeah, this has worked before. That guy also has to keep things in mind and not forget any details, but it's comes a point that this doesn't scale. So in those cases, what we can do is to have a migration linter, and the popular tool is Squawk. So what you do is you generate just a plain SQL query of statements from your migrations library or tool that you're using, and feed it to your linter, and the linter should help you prevent a lot of errors that will come up in production or prevent doing any things that might be a problem in the future, like let's say the case of the big integer over small integer. So, and there are a lot of rules that you can use to guard yourself. So you can put it in a pre-commit or just as a test in your CI. It doesn't cover everything, so it depends on the tool. You might need to use multiple tools or just add some custom rules depending on your application.
I've put the link on in the chat if people want to see. So that's a project, works with Postgres and then works with Yugabyte, and it checks the migration script for any mistake that can be seen.
Yep. So I didn't mention in the previous slide what can go wrong, and we'll just go over them one by one and see how we can do them. So one way is to just simply write robust migrations. So the simplest one would be to just add a new column and then create an index on that column. So in this case, we have a new AO column on users table. But if this migration fails in the middle for whatever reason, like either just the server running the migration going down or the server where the query is being run against, since in our case it's a distributed database, can also go down and the cluster still continue. So the best way in this case would be to have migrations that can be easily retried. So the simplest case would be to create a new column only if it doesn't exist, so it doesn't raise an error. The same will be with the index, to create an index only if it doesn't exist. So let's say if we had a migration with only these two statements, it is pretty easy to be retried safely. And this can be done for many other cases, like creating a table or dropping a constraint or a table or an index or a column or a couple of other things that I haven't mentioned here, but there are also many statements that cannot be retried like that. Let's say the simplest one is create or drop database. Another one would be with the changing enum values. In this case, you can just do the query and make sure to capture the exception or the DB error that you get back, and then to handle your logic failover there. So depending on what in the case on what this statement is, let's say in the case of dropping, then you'll get an error that the database doesn't exist. You can just ignore it and it's safe. The other way is to just query the system views. Like you can query for any type of object in the database there, and then act accordingly. Like an object is missing, so you have to create it, or it exists or it hasn't been updated. You still have to be careful of concurrency in this case, because you don't want to run several migrations at the same time, and each one querying the system views and someone creating something and the other didn't see it. Another case that we have is prevent adding a required field. So if you add a new field with a required volatile column default value, then the database will have to rewrite all rows. So having a big table that will require a lot of time, we will have to wait. The table will be locked. So we are trying to prevent it. This, in the case when the default value is the non-volatile value, the value is actually just stored in the metadata of the database. So this is pretty safe to do. But in the case of volatile value, then we have to make several steps, pretty small ones.
Volatile is like if there is a default to set the current date, that's something that cannot be in the dictionary. If the default is say 0 instead of null, then that's that's possible.
Yeah, volatile is like dynamic. So
Yeah.
because if it's fixed, let's say just a plain number or plain string, then that simple plain number can be stored in the metadata and you don't have to go back and rewrite all rows. Well, if it's a dynamic value that has to be different for each row, then
Yeah.
it has to do the rewrite. So the solution in this case would be to break this migration into several steps, such as adding first the field as nullable, then we set the default for it, so new rows will actually have a value. Then we can create a partial index on all the rows that the column is still null. So then we can query for rows in batches that still don't have a value and backfill them asynchronously little by little in a loop, let's say. And we can then remove the nullability because all of the rows have a value and the default is already set on step 2. And then we can remove the partial index because we don't need it anymore. And another alternative to the third step about using the partial index would be to do full table scans using the YB hash code function, which helps us to make scalable distributed scans, full table scans, but also efficient full table scans. So another one is regarding always defining a primary key. Tables in Yugabyte are stored clustered on disk by their primary key. So there always exists a primary key compared to Postgres, which uses a heap table, and the primary key is optional. So there always is a primary key, and if one is not defined, then a new hidden one is created and used internally and not exposed. And the same thing happens for indexes. They are also clustered by the key columns, by the columns that they are indexing. And they also store the primary key of the table to use as the location to find the row. So if you change the primary key as an example, you also have to change and update all indexes. While in the case of Postgres, you have to always update indexes, even if you don't change the value of an indexed column, because the row location changes. While in our case, it does not, because the primary key doesn't change when you update the row. So you don't need to you don't need to rewrite them. So the solution in this case is to always define a primary key. In the case of Squawk, you can have a rule that always requires the primary key, let's say, and it should show an error when you try to run the linter over the migration script. Another one is to not change the primary key of a table. In the case of Postgres, you can update the primary key of a table and it will do a full table rewrite underneath, and then it will all be in a transaction and it will be nice. But when you have a big cluster or a synchronous replication or a lot of data in the table, or let's say multi-region, all these separate things making it worse, and it will have the log will be pretty big. So while this works in Postgres, it breaks in large installations. So
yeah, because Postgres is transactional for the DDL, but holds an exclusive lock for the world change.
yeah.
So there is a lock for the metadata change in the catalog, and the lock is held if within the same transaction you have a lot of data to move. So yeah, with large data, doing everything in a transaction is probably not a good idea in Postgres. Yeah.
Yep. So even though Postgres is allowed DBA probably won't allow you this migration to just change a big table into, which is the primary key of a big table. And in the case of Yugabyte, this isn't possible. So what we do is actually we rewrite the whole table underneath and then write the data to the new table. And then in the end, we do a rename. But during this time, you can lose writes while the online rewrite is happening. So we have a small link in the end on the alter table DDL command on docs that explains how everything works. But for this case, we want, if we have concurrent transactions working with the table, we want to do the solution instead, which is create a new table, and then we'll write on both of them, and then we'll slowly move reads only to the new table while trying to verify that they have the same data. We can, as an example, read from both of them and make sure they return the same data, let's say, because we're still in transactional reads and writes when we do. And then
yeah, that's an important point. Maybe I will repeat it for people who listen to that. We support alter table add primary key, but we support it mostly for empty tables. For example, to import from a pgdump or something like that. For the moment, we do not take an exclusive lock, and then that means that the application shouldn't write to the tables while we change that. Yeah.
Yeah, mostly if there are no concurrent other users reading and writing on it, then it's safe, even with the tables with a lot of data. So that's the whole issue with the concurrency while the migration is happening. So then after we can slowly move reads to the new table, and we can, step 3 there in the solution, we can verify the data by reading from both tables. Then we have to slowly remove reading from the old table. And then what we do is we just do a rename to the old table, because you never know, some hidden service that is still using it, and you don't want to get that error that the table doesn't exist yet, like after 1 week when that cron job runs. So it's much easier to hotfix it with just a rename than to drop it now and change the code. And let's say it was a cron job, you just rename back and run the cron job again, compared to changing the code of the cron job to use the new table. Because it's not just new table, but it might be even a complete different schema. So then you have to change the whole code of the cron job that runs once a week, instead of just renaming the table. And after some time, we just hope that everything should be fine, and finally drop the table, the old one. Another one that we have is to always use the timestamp with time zone. The storage underneath is the same. It feels like timestamp with time zone actually stores the time zone together. So, but actually, no, it's just time zone aware, and the storage underneath is the same. But the timestamp TZ column also helps with many cases that you need to use them, like when inserting using the correct time zone, or when selecting returning in the time zone of the session, or also with the transformations of the timestamp. There is kind of no real reason to use timestamps without a time zone. So this solution would be to just use timestamp with time zone. So you just got this knowledge, and then you'll go to your application and just change all your timestamp columns to be with time zone. But actually this is not safe, because it will still do a full table rewrite. So even though the storage size underneath is the same, the offset, depending on the time zone, really are not. And this being an open source database, it can be done, that it can be migration with no table rewrite, but somebody has to do it, and nobody has yet done it. So currently it works as a full table rewrite, and we should treat it as like we did in the previous slide, which would be to just create another table, etc., etc. Another one is the truncate is not transactional. Truncate, it's actually not transactional even in Postgres, even though it feels like that. You put it inside the transaction, the transaction commit, it says no errors, no notice, but actually it's not, because it's dropping files, and another concurrent transaction, let's say you do truncate, the other transaction won't see the rows, because it's not MVCC safe, even in Postgres. And while in Yugabyte, it's just not transactional. So the solution here is to not expect truncate to be transactional in your migrations or anywhere. And you should avoid using it in cases like multi-step transaction, or when you have concurrent reads and writes on the same table and you want things to be exactly correct. So it depends on the case. You don't want to use it. So it will be heavier in the case of deleting a large table, but it will be correct using just delete. The other one is a thing that happens often is that developers include as much stuff as possible when the application starts, like run migrations, create missing users, check for anything that should be created or for everything that might go wrong. And then when you do a deployment and then you have 10 new application servers, each one starting a new version and each one running a migration, and often migrations cannot be transactional, even if some of them can, like we explained the first slide. And then you'll get on errors because you're trying to do multiple migrations at the same time from multiple clients. So this solution is to just not do it, and you should run migrations as part of a deployment task. So even though you might have 100 clients, server clients, you just have one deployment task, and that has inside one migration task. It's not the code that gets executed on application start. Another
and I
one
think
is
it's also much better to know exactly when it runs, because the people who start the application may not have the skills to fix the issue about the migration. Yeah.
usually it will run when you do the new deploy, but so it will run at the same time as when starting the new application will be started by the new deployment, so they will run at the same time, I guess, but it should be as a separate task and not just part of the application start lifecycle.
Mm-hmm.
So another issue is removing indexes still being used by queries. It's a bit hard, and the problem is that an index is being used by queries, it's very efficient, and then you drop the index. Now these queries are doing, let's say, full index scan of another index, or a table scan, or something in the middle, and you get a lot of increased load on your database. And the way to fix it is to make sure indexes aren't being used before dropping them, because you may grind your cluster into a halt, since it can be a popular query that just ends up being as a full table scan, and it will just slow everything down. And in this case, we have Franck that has written an article on how to check index usage monitoring in Yugabyte and in Postgres. And it's a little big, so you should just go read it and keep it in mind. Another one is running tests on several schema versions. So when you have a serial deployment, or let's say a blue-green deployment in production, you want all your features, all your code paths that are hopefully backed up by integration tests would be at best to work with both schema versions, the one that is current and the one that is just being upgraded while the deployment just started. So you have to make sure your tests run on at least 2 schema versions. So no feature breaks while the deployment or migrations started until it finishes. So if you have a big deployment, let's say many clients, and you are doing serially, or if you have a big migration, let's say you are migrating a big table that will take a couple of hours to do the full rewrite, then you just want to be sure that all your features backed by test cases actually work on while this whole thing process is working. And this also, we just have to keep in mind that to still run the migrations as part of the deployment and to treat it as a thing that we don't want to run multiple migrations. Because if the migration failed, let's say you did the full table rewrite and it failed in the middle, but then new code came up with another migration, you still want to keep the migrations separate because you don't want to now test for 3 versions, because the new code with the new migration actually doesn't test on the -2 version of the schema. So try to have migrations as sequential and monolithic as possible.
Yeah, makes sense. Keep it
The other
simple.
one, yep. The other one is data migrations breaking because of big data. As we said at first, is that we can do like a full table rewrite or just write a CSV from the file system or downloading it from somewhere and just push it all to the database. But this might break in production when you have high load or when you're trying also to do schema migrations at the same time. So the safest solution would be to always batch data as much as possible, like not have update queries that update a full table. And for simpler code, this is just general programming, would be to just have even a function that just does a batch, not a function that you just update a single row, but just use a batch of 1 in, just so you don't have code for a single update and for a batch update. So another one would be load testing while running migrations. This might need a little bit of budget, so maybe you have to be a little bit large company to do it. But in a way, you can only really know in production if something will be very heavy weight in a way. And the only way to really know that is to just reproduce it. Maybe reproduce it in a smaller cluster, but the perfect way would be to just run a load test. And then while the load test is running, do the migrations and check if anything went wrong with the SLAs or the latencies of the queries, or however you are measuring the speed of your application. The other one is mixing data and schema, which it works until it doesn't, and it will happen in the worst case possible, like in production under heavy load with a lot of concurrent clients. So the solution in this case would be to just don't, and you have to just batch updating rows like we talked previously, and try to do them in a long job that works little by little. And still, just like we talked previously, to not allow multiple migrations running at the same time. So they should be mostly be serial. Another one is to be prepared for failed migrations. They will happen eventually, and they will happen in CI. You will catch it. Happen in staging. You will still catch it, but eventually it will happen in production because everything else worked nice, but it wasn't really production. So what we can do to be prepared was to have downgrade migrations, something that we can just do a downgrade in production, and hopefully it still works. And you have to test it, so it might look like a waste of time because you are always writing downgrades and never running them, but always testing them. But in the rare occasion, you will need it and you will have it ready. So it kind of depends on how much money you'll lose when the migration will fail. So mostly required for big applications. Another one is fast schema migrations when doing automated testing. We have a couple of users or enterprises with, let's say, thousands of objects, which just take time to even create them as empty ones, just to create 1,000 tables with indexes and constraints and everything. And I'm pretty fanatic about developer programming time, so there's also a solution for this, but it's a little bit complex and will require a little bit custom code depending on your CI system. But the fastest way in this, so this is just better schema migrations in the automated testing scenario. And the fastest way would be to create all the schema and maybe even import the data that you have to have for testing, and then you should let's say we're using YugabyteDB in the CI, and you create the schema, you insert the data, the fixtures that you might need, and then you close the database and you cache the whole data directory of YugabyteDB. So on the next test run, you just start from there and everything is ready. It should be like 1 or 2 seconds, depending on the amount of data, because the schema doesn't really occupy a lot of data. So this should be the fastest way that you can have fast schema migrations in the automated testing.
It's a physical snapshot of metadata and data from the system. Yeah, faster than recreating the object.
Yeah, just like you have in your dev machine where you start Yugabyte after you restart your computer. So it should be the same thing and be extremely fast. And there are some small things that you can do is to use a collocated database, but this depends also. You don't want to use the collocated database in the, let's say, load testing migrations case if you don't have a collocated database in production. So this should be only to have it as fast as possible, only for an integration test, let's say. Well,
maybe we can mention so collocated databases is where you put a lot of small tables in one tablet, the tables that you don't want to distribute. So of course it's faster to create because it doesn't have to create tablets in all servers.
Yeah.
But it may have a different behavior than in production. So probably a good way to test, but still important to test something that is like in production before doing it in production.
Yeah, so it shouldn't make a very big difference in this case. So you can even not use it because your CI cache will just tar all your files, and it should not be a big difference to just create a couple more extra files in the case of not collocated database. And you can use the hash of the migrations directory as the cache key. So when you add new migrations, they will be recreated automatically in by your CI. And I guess that's all. So
Yeah,
I don't know
perfect.
how
We have
are with time.
an important remark from David. When you have a lot of data to move and you do it by batch, so that what David is saying, be careful when you batch with a limit X offset Y because of the performance. And basically, I would like that offset. Probably there is no
Offset
real good
scale,
case for offset in SQL. So the idea there is just to do a batch on a range, for example, and to keep the number of the last one that was processed, and rather than doing offset, just using the ID higher than the other. So for that, you need to know if you are hash sharded or range sharded. If you are hash sharded, you can use the YB hash code. If you are range sharded, then you will define the last point that was processed from the primary key.
Yeah, or using your YB hash code if you are just scanning the table for any null columns that we talked at the first migration example. But
what
yeah,
I would recommend in
offset.
that case is always look at the execution plan before. When we try to parallelize something, always look at the execution plan. The execution plan can show if it's scalable or not. If it has to read all the rows and then order them just to get a small batch, then you don't have the benefit of batching.
Yep, and offset doesn't scale. So yeah, I agree with David there.
Okay, perfect. A lot of tips there. And
regarding an example for YB hash code, there should be examples in our documentation side. You can just search for YB hash code in our docs page, and
basically YB hash code is the function that is used to hash to distribute, and then data is stored in tablets in ranges of hash codes, and we push down the conditions on YB hash code, equality or inequality, so that it touches only one tablet. So the big advantage is that you process by batch, but you also process probably a single tablet rather than sending writes in all the cluster. And that's the goal. For the application, we want a high throughput and then parallelize everything. But for migration, we don't want to take all the resources. So it makes sense to focus on
what's important ranges. Is that it will be efficient in the case of YB hash code. So it will go at the correct node that has the tablet leader and do an efficient sequential scan there.
Yeah. Okay, perfect. Let's see if there are more questions, but we are a bit over time, so that's perfect. Thank you, Dorian. And if people have questions, as usual, they can ask the question on Slack, but also anyway, if you ask questions on Stack Overflow, on Slack, on the forum, then there is a good chance that Dorian will answer.
Yep. So I guess
thank you very much
for coming, and see you on the
next Friday. Yeah.